Let's see another LeetCode problem. It's a restore IP address. It's a medium level problem. Let's try to understand this and we'll go for the solution. So it's saying a valid IP address consists of exactly 4 integers separated by single dots. Each integer is between 0 to 2255 and cannot have leading zeros. So like there is a string given, and from this string we need to find out all the possible IP address. So if you see in this example here, each section in a IP address this max can have 255. So that's given here, 255, and it can be 0 to 255, and we need to put the dot here, and we can see there are 3 dots. So we need to generate the IP addresses from this string. So that's the problem. If you see here, from this string we can generate only one, and from this string we can generate this many. So we need to find out a way how to generate this. So the solution can be, we can try all the possible ways of generating the IP address. So we need the recursion here, and when we try the recursion, we can try from this, like we can take index 0. So saying, okay, let's put the dot to 1 dot here, 2. So that means we can try with this index 0, and we can try with all the possible sections. Like if I try with this 2, then this 2 can be one possible IP address section. Other can be 2 point, I can say 2.55. We can say the third one can be 255. So is the 255? Yeah, that's allowed, 255. So in this way, like, we can generate all the possible IP addresses. So first we can try with 2. So I can see, if I say put the 1 dot here, then try with 2. We can try with the 55, like first section can be 55. Third section, if I say the third section is 552. So anyway, the 552 is not the valid IP address, so we can ignore that. But we can try all these combinations. So when we use the recursion, we need like 3 level of recursion. Like we can when I say that 1 dot, 2 dot, and the 3 dot, then you can try with this 0, and from here. So, and we need the 3 level of recursion, and each recursion again continue and proceed with the next item, and keep trying all the combinations, and if it finds in the right IP address, we can collect in a variable. Yeah. So if, let's say, if the one recursion start from the 2, then it can take the 2 as a valid IP address section, and then again the same recursion again it will take another 3 level of the. Yeah, so for the example, let's try to understand a little bit about this. So let's say it's a 1 2 3 4 5 6, and from here, if you need the recursion, we can try with like 1. We can try with 1. We can try with, like, if I say put the 1 dot here, so 1 is the valid section. Again we can put the dot here, then 12 can be another valid section. If I put 2 dot here, if I put the again another dot, then 1 2 3 can be valid section. So we can try this 3 level of recursion here. Again, from the one we come here like the 1, and from 1 again we try another 3 level of recursions. So we can say like the this recursion will take the same string but move it. One has already been taken, then 2 3 4 5 6. Again, from it will put the 1 dot at 2, so maybe 2 1 dot, and then another dot 2 3, another dot 2 3 4. So this recursion continue here. Again, the second level of recursion also continue, third recursion also continue, and we also keep checking the valid IP sections, and then when we find the valid IP address, we can put that in a result. So that is the basic concept. Let's see the code and we'll get the clear understanding. There are few lines of the code, we'll see that. Okay, so come here and let's write the function. Like I can say the func generate IP address. Generate IP address, that's the function. We can call this function here. We can pass few parameters, like let's say we can start the index with 0. I can pass index 0. I need to pass the string also, so let's pass the string first, string, and start with the 0. We can also pass the result, where we want to accumulate all the result when we call this recursive function. Then for that, let me define the result. So result is, that should be the valid IP address, it should be a string. So I can pass this result also. So this time I'm going to pass address of result, because I need to collect all the valid IP address. We also need one more variable, like to find this current IP address, because we take the each section, and we also when we get the each section, if it's a valid IP address section, then we'll keep passing that, and we also keep adding the dot over there. And if it is a valid IP address, then we can put that in a current IP address, and we can also add that in a result. So for that we need a variable, it's current IP address, and this is the string. And then we can pass this also here. So let me pass current IP address. So okay, so we are good here. So we pass this, and also when we find this IP address, then we need to put the dot there. So pass the dot also, like so for the dot count, like I can say the dot count, I can say in the beginning it's a 0. Let's pass this dot also. Okay, so we need all these things in a function definitions here. So string, and then I is int, dot is also int, current IP address, that's a string, and this one is star string. Let me put it here, result. Okay, so that's all about this. Let's call the recursion and see how it's going to happen here. So first call for, and then I'm going to define a variable j is equal to 0 and j less than, okay, so j0 and j less than, we need to try with, you know, the three dots, like we need a 3 level of recursions. So post 2 dot maybe 25 dot 255 dot, so in that case I can say j less than I plus, in the beginning you can put j is equal to I, so I value is it's a 0 in the beginning, and I can say j less than I plus 3. But when we say the j less than I plus 3, then it will always try with the 3 dots. So we'll see, you know, it will also get the one item, like max 3 items in the string. But in a string also we keep moving the cursor in the string. So sometimes, you know, the situations come where the string length is less than I plus 3, so in a recursion, and in that case there will be out of index, out of bound error. So to avoid that, we can also check like which one is the minimum, whether this is the minimum or the string length is minimum. So for that, let's define one variable here, func min function. If a less than b, return a, otherwise return b. So I can use the function here, so mean I less than, so I can use the function mean I less than or length of a string. So whichever is the minimum, it will take that. So, and here j plus plus. So first of all, we need to find out, you know, the each section of the IP. So I can say each IP section here, one variable, and that I can try with I, like I can say s, and from the I to j plus 1. So if you try, like if you take this example, let's say I is 0 and we make j also 0. So if I say I and j plus 1, so 1, so in that case it will take this 2. And the next time, again this is the loop, the next time j, we are increasing j, so j will come to this 5. So that is j value is, like in this example, it's a 1. So in that case, if you say I plus j plus 1, then j was the 1, so 1 1 2. So if I say the 0 to 2, so 0 1 2, so before this 5, like it will take 2 5, and the recursion start with that. So that, so in a first case, in a first level of recursions, it was the 2 was taken, that means we put the dot here, and the second time it's a 25 will be taken, third time 255 will be taken. It will run mostly in a 3, max 3 if it is so max 3, so that's why I'm just giving I plus 3. So we got this each IP section. Now we need to convert this IP section in an integer, so that we know whether that section is valid IP address or not. So each IP section, and say int here, I can use the function str conversion a to I, and I can pass this. So we got this thing also. So here first I can check the condition if this each IP section int is less than 255, or we can say less than 255, let me put equal to, or less than 256, that's same, or I can say greater than 255. If it is greater than 255, then we do not want to do anything, we just say continue. So that's the one condition. We'll just continue this loop and try with another dot. If it is greater than, and other condition we can check here. If it is it's saying cannot have leading zeros, so cannot have leading zero. So in this case, like I can take, so if I say the leading zero, so that means that length should be more than 1. So I can check that condition also. If length of this each IP section is greater than 1, and if it is greater than 1, then and the first index has 0, then we can ignore that also. So this one equal to 0, then continue this also. Otherwise I can call this function again, but we need to also accumulate this result also. So let's put that, like call this function first, and this time I need to try with the next item in a string. So I can say this j+1 here, that's the first one is a string, so make it a string, and so j+1 dot, so I can say dot +1 also, and the current IP address. So I need to find out this current IP address. So the current IP address is whatever the current IP address plus whatever if found in each section. The first time what we put in a current IP, that's we didn't put anything. Okay, that's good. Let's say, yeah, that's fine. Current IP each IP section, and then we put one dot here, and then we can pass this result. Okay, so the current IP address has the valid IP address. So we can check this condition, like we need a base condition, how to, like this is the recursion, it's keep going on. So we need the exit condition. So the dot, we are increasing dot, and if the dot is the greater than 4, because I need like one section, 2 section, 3 section, and 4. So I want to put the 1 dot here also at the end. In that way, I can take all these things and I can remove the last dot. But if it is a dot is greater than 4, then we do not want, we want to ignore the result. So here, like let's create the exit condition. If dot greater than 4, then just return. Or I can say, if so we keep moving this index. So if the index is like, if this I is I8, we can say, so let's try with the dot. So dot equal to 4, if the dot is 4, and also we need to check if I is equal to length of string. So if the dot 4 and we reach the end of the this is a string. So in that case we want to accumulate the current IP address and we want to put to the result, and that's it. At the end we want to return that. So let's try this. So result star result is equal to append star result and then this current IP address. So we put that also and again return from here. So that's all. Return the result here. Let's see if it works. Let's check for the syntax. So we accumulated the result here, so return result. Line 25. Okay, we need the colon because this is a new variable. Let's see the expected output is 255 135. That's the first one is correct. Okay, so last one, okay, we need to remove this dot somehow. Okay, so from here we got the current IP address. You can say current IP address from, okay, we need to find out the last index. So let's find out the last index. Last index is equal to, so string function strings last index, and from the current IP address this, so we'll get the last index here, and from current IP address I need everything from 0 to last index. So if I say the last index, it will be the strings will be, substring will be before that index, last index. So that will be, I think it will be good now. Accepted, try to submit. Okay, it's good. Let's see Java solutions also for this. So Java is the same thing I have put here, I0 dot and then current IP, generate IP address. Similar logic, we can come to this section. There is a loop I1 and then j is equal to I, j less than this 3, and whatever is the minimum length of the string or the 3. Then we are collecting each IP section string, converting to the int, checking is greater than 255, continue, is greater than 1, and if it is the 0 then continue, and the recursion goes here. That's a min function, and our base condition is .4 and I equal to the end of this or length of the string. Then we need to find out current IP, we put that in a result. So that's the same logic here. So that's all for today. Thank you.